In this video, we are going to look at solving trigonometric integrals. Our goal is, by using trig identities combined with u substitution, we'd like to find integrals of the form the integral of sine to some power times cosine to another power dx, where m and n are integers. In this section, it will be important for us to recall identities from trigonometry. So here are various identities that would be useful to memorize for this section. Feel free to pause the video and take a look at these. Example 1 asks us to find the indefinite integral of cosine to the fourth power times sine times dx. So here we're going to use u substitution. I'm going to set u equal to cosine of x. And then du is going to equal negative sine of x dx. And so our original integral is equal to u to the fourth power. And then here, if I solve for negative du, that gives me sine of x dx. So what I can do is I can replace sine of x dx with negative du. I'm going to go ahead and factor out my negative sign. And this gives me negative u to the fifth power over 5 plus c. And then we just want to make sure that we plug in our original u back in so that our final answer is in terms of x. And this is our final answer. Example 2 wants us to find the indefinite integral of sine cubed of x dx, and it gives us a hint to use the Pythagorean identity sine squared x plus cosine squared x is equal to 1. Then it asks us to make a substitution. So I'm going to take the hint, and I'm going to take my integrand, and I'm going to rewrite it as sine squared x times sine of x dx. And what that allows me to do is, if I take my Pythagorean identity and I solve it for sine squared x, then this tells me that sine squared x is equal to 1 minus cosine squared x. And so I can make that swap here. And then from here, I can use u substitution. So I'm going to set u equal to cosine of x. And then that's going to give me that du is equal to negative sine of x dx. And then if I solve for, or if I multiply both sides by negative 1, I get negative du is equal to sine of x times dx. And then going back to our original integral, that's going to be equal to 1 minus u squared, and then sine of x dx is going to get replaced with negative du. So I'm going to factor out a negative sign. And now I just want to go ahead and substitute back in my u value. And if you'd like, you can distribute in the negative sign. I'm just going to leave it factored out. And this is our final answer. Example 3 asks us to find the integral of cosine cubed of x over the square root of sine of x dx. We're also given a hint to use the Pythagorean identity again and then make a substitution. So I'm going to take my numerator and I'm going to rewrite it as cosine squared x times cosine of x dx, and then still over the square root of the sine of x. And then if I use my Pythagorean identity, I can rewrite cosine squared as 1 minus sine squared. And now I'm going to go ahead and use u substitution. So I'm going to make u equal to sine of x. And then that's going to give us du is equal to cosine of x dx. So now this is equal to 1 minus u squared over the square root of u, which I'm going to rewrite as u to the 1/2 power. And then I know that cosine of x dx is equal to du, so I'll sub that in. And now what I want to do is I want to split this up into two fractions. So this is equivalent to 1 over u to the 1/2 power minus u squared over u to the 1/2 power du. And now I'm going to rewrite that as u to the negative 1/2 power minus u to the 3/2 power du. And this is going to make it easier for us to use the power rule. So now I'm going to increase the power by 1 and divide by my new power. So I have u to the 1/2 power divided by 1/2 is the same thing as multiplying by 2, and then minus 2/5 u to the 5/2 power plus c. And now I just want to go ahead and plug in my original u value. So I have 2 times sine raised to the 1/2 power is the same thing as the square root of sine. And then if I raise u to the 5/2 power, that's the same thing as the square root of sine to the 5th power. And then I have my constant of integration. So there is our final answer. Example 4 asks us to find the indefinite integral of sine to the 5th power of x times cosine squared x dx. And it gives us a hint, so we're going to rewrite sine to the 5th as sine squared x, quantity squared. I'm going to leave cosine the same, and notice that I only have 4 sines being multiplied, so I need another sine to make it 5 in total. Now what I can do is I can take my sine squared x and rewrite that as 1 minus cosine squared x using the Pythagorean identity. And from here we want to go ahead and use u substitution. So we're going to set u equal to cosine of x. That's going to make du equal to negative sine of x dx. And then if I multiply through by negative 1, I get negative du is equal to sine of x times dx. And notice that that appears in my integrand. So now I can go ahead and do some substitutions. I get 1 minus u squared quantity squared times u squared, and then sine of x dx is getting replaced with negative du. I'm going to go ahead and factor out the negative sign, and if you expand out the integrand, so if you square or FOIL 1 minus u squared times 1 minus u squared and then distribute in the u squared, you should get that your expanded polynomial is 1 minus 2u squared plus u to the 4th power du. And then from here, I'm just going to go ahead and use the power rule. It looks like I forgot about this u squared here, so let me write that in. And then what we want to do is we want to distribute that. So we have negative integral of u squared minus 2u to the 4th plus u to the 6th du. Now we can use the power rule. Okay, so now at this point, we want to plug cosine back in for u. I'm going to leave the negative sign factored out, but you can distribute it if you'd like. And there's our final answer. Example 5 wants us to find the indefinite integral of sine to the 7th power of x times cosine to the 5th power of x dx. The algebra here is long, so just set up the integral / substitution. Don't evaluate. So that's nice. We don't actually have to integrate. We just need to set up our integral. So I'm going to go ahead and rewrite the sine portion of this. So we have sine squared x, and we're going to raise it to the 3rd power. Notice that that exponent doesn't give us 7, so I'm going to need a sign at the end. And then just like in previous examples, the thing inside of the brackets using the Pythagorean identity, I can rewrite in terms of cosine. So u is going to be cosine of x, and then du is equal to negative sine of x dx, and then if I multiply through by -1, I get that negative du is equal to sine of x dx. So back to our integral, I can start doing some substitution now. I have 1 minus u squared, quantity cubed, times u to the 5th power, and then sine of x dx is getting replaced with negative du. And then, just like previously, I like to factor out the negative sign outside of the integral, and maybe I'll move the u to the 5th to the front. And it just asks us to set up the integral, so I'm going to go ahead and stop here. Example 6 says, in general, how do you go about trying to find the integral of sine to the mth power of x times cosine to the nth power of x dx, where m is an odd integer? Hint, consider some of the previous examples. So what we've seen previously is we want to rewrite our sine so that it can be broken up into something squared. So what I'm going to do is I'm going to write this as sine squared x, and the power that's going to be left over is, because m is an odd number, I can't divide it by 2 and get an integer. So what I need to do is I need to subtract 1 from it and then divide by 2. And that means that we have a leftover sign, which we've seen in previous examples. So I'm going to go ahead and write my sign here at the end, like we've been doing. And at this stage, we can start to do our u substitution. So u is going to equal, oh, actually, we should change the inside of the bracket like we've been doing to be in terms of cosine using our Pythagorean identity. Okay, so now we can do our u substitution, where we're going to set u to be equal to cosine of x, and then du equals negative sine of x dx. And we get negative du is equal to sine of x times dx. So then we have the integral of 1 minus u squared to the power of m minus 1 over 2 times u to the nth power times negative du. And then I'm going to factor out that negative sign and put it in the front of my integral. And then I have du here. So this is our final answer. Example 7 says, note that this same kind of trick works when the power on cosine is odd. To check that you understand, what trig identity and what u substitution would you use to integrate cosine cubed times sine squared dx? For this question, we don't need to evaluate the integral. So I have cosine cubed x times sine squared x dx. What we're going to do, just like we did with sine, is I'm going to break up cosine squared x times sine squared x, and then I have a cosine left over at the end, because I have 3 of them being multiplied together. And then it asks what trig identity would we use. We're going to change cosine squared using the Pythagorean identity to 1 minus sine squared x. And then from here, we can start to use our u substitution. So we're going to make u equal to sine of x, and then du is going to equal cosine of x dx. So we get this is equal to 1 minus u squared times u squared, and then the last part gets replaced with du. So there is our final answer for this one.